morning, trig fans. How are we on this fine Tuesday morning? Hope everything's going well in your household. Hope you're doing well. It's a little cloudy, a little rainy outside, but the weatherman says it's going to warm up a little bit. So hopefully it'll be like yesterday, which was a pretty nice day. Yesterday we talked about the inverse or arc trig functions. Once again, do please complete the questions at the very end. I use that to add on to your evaluations at the end of the week. So they get counted into the evaluations to help you in regards to your grade, and also help you give me a little checkup on making sure that you're keeping up with the material also. So do please do these little exit tickets at the end of the lesson there. Today we're going to work with the law of cosines. Tomorrow what we'll do is we'll combine both of these together in a worksheet where we have sort of like a review sheet for the arc trig functions and the law of cosines. That will be tomorrow. And then Thursday we will have the evaluation also on the arc trig functions and the law of cosines that we'll be talking about today. And then Friday will be sort of like a makeup day in regards to if you need an extra day to get things taken care of, do it on Friday then. So that will be the rest of the week in regards to the law of cosines and the arc trig and what we were doing here in trig class. Today we're going to talk about the law of cosines, and we're going to, once again, this should be review for you from back in Dr. Clark's class down the way there when you were in geometry. You dealt with the law of sines and you dealt with the law of cosines. Today we're just going to deal with the law of cosines. Some properties of triangles that we have to deal with here. We just have to remind ourselves of. The angle sum of the angles of a triangle equals 180 degrees. If you add up all the angles of a triangle, they add up to 180 degrees. The smallest measure of an angle must be opposite the shortest side. Okay, so if I have the smallest measure of my angle, that's going to be opposite the shortest side. And the largest angle must be opposite the longest side. So when I'm looking at a triangle, the biggest angle has to be opposite the biggest side, and the smallest angle has to be opposite the smallest side. Because I don't have that big of an opening here, my side opposite is not going to be very big. But if I have a big opening here, well, my side opposite is going to be a lot bigger then. So small is small, big is big. So if we look opposite our angles, we'll be able to tell what type of side will be the longest side. And the other thing that we learned about in geometry was the length of any two sides of a triangle when added together has to be greater than the third side. If I add two sides of a triangle together, it has to be greater than the third side. So if I have a side that is 2, a side that is 3, and a side that is 7, well, I need to be able to add these two together to be bigger than this side, which is not. So the value of 7 is not going to give us a triangle then. Okay, this will not give us a triangle. Okay, because this adding 2 and 3 together has to be bigger than this angle right on the side. We also have if we have a right triangle, we have our good old buddy Pythagoras here. Our good old buddy Pythagoras, if we have a right triangle which says length squared plus another leg squared equals the hypotenuse squared. And also if we have the right triangle, we have the sine, cosine, and tangent. We have our trigonometric Indian for sine, cosine, and tangent that we can utilize to be able to solve through a right triangle. Okay, another aspect of triangles is for any triangle, the vertices are labeled with the capital letters and a side opposite are labeled with the lowercase of the vertex opposite. What that means, and this is a nomenclature that typically occurs, if this angle is big A, here is my side opposite. This is labeled with a lowercase a. Here is big B. The side opposite that is little b. And here is big C. And the side opposite we have little c. Well, if we have an angle here and we have a right triangle and we know this is 73 degrees, what we're able to do is solve for any side of this triangle if I have a right angle, which I do. And we're just going to solve for little b here, we're going to solve for little b. We have little b, we have this angle, or this side, and we know this angle right here. So we ask ourselves, which trig ratio relates this angle to the side and this side? And that is correct, that is the tangent. The tangent of 73 degrees is equal to little b over 10. And we've solved these problems. We did this in January when we were working through these triangle problems. We can solve this by multiplying both sides by a value of 10. So we have b is equal to 10 times the tangent of 73 degrees. And if I would click and clack that through my calculator, we have 10 tangent of 73. We get 32.7 units. So that is the length of little b. And if I wanted to, I could use the cosine of 73 as 10 over c and solve for my little c. And those are things that we have done throughout our mathematical career when we were talking about geometry and working with right triangles. We did it at the beginning of trig class here. The problem we run into is we need to make sure that we have a right angle to use sine, cosine, tangent, and also the Pythagorean theorem. What happens when we don't have a right triangle? Everything in the world does not come down to a right triangle, but we still want to be able to solve the right triangle. And when we talk about solving the right triangle or solving the triangles, we're just looking for lengths of sides. Okay, we're looking for lengths of sides or measures of angles. That's what it means by solving a triangle. So what happens when the triangle is not a right triangle? What happens? We still want to be able to get a relationship between the lengths of the sides and the measures of the angles. Okay, if we don't have the lengths of sides and measure the angles, it doesn't look good. So we want to be able to solve for these things. So that's where we're going to develop what is called the law of cosines. And we're going to go through how we develop this. If we have triangle ABC, and if we take a look at triangle ABC, here is big A, that means this is little a, because that's the side opposite. Here's big B, this is little b. If this is big C, this is little c. And once again, if I'm going too fast, just hit the pause button. That's okay, I won't be offended. We want to get relationships between angles A, B, and C and little a, little b, little c. Well, how do we go about doing this? Well, we're going to draw in an auxiliary line. And this is going to be an altitude. And if we talk about an altitude, that is the height of this triangle H. And what this height of this triangle H will give us is two right angles. That is the definition of an altitude. So I just drew a line down here and called this my H, my altitude here. The other thing we're going to have to add in here is we're going to have to add in some extra little values here. If I label, because what I've created is I've created two right triangles. I've created two right triangles. And if I have right triangles, I have all the ideas from the other side that I can utilize. I need to introduce another variable, an x, which is going to be the length of this right here at the bottom of my triangle number 1. Well, if the entire length is c and this length is x, this entire length is c, this length is x, what is the measure from the altitude to angle B? What is this measure right here? The entire length is c, this is x, what was this? Well, let's think about this. If this was 10, this was 7, what's the measure of this have to be? That's correct, it has to be 3. Well, how'd you get that? Well, you subtracted 10 minus 7. So what we can do here is the measure of this length is c minus x. C minus x. So let's take a look at these two right triangles and let's use our Pythagorean theorem. if we look at triangle number 1, right triangle number 1. Here's right triangle number 1. We have C here, we have A, and then we have a right angle. This is X, this is length B, this is length H. And if I use my Pythagorean theorem, we have x squared plus h squared is equal to b squared. We're just using our Pythagorean theorem here. Leg squared plus leg squared equals the hypotenuse squared. If we look at triangle number 2, what we have in triangle number 2, we have A there, we have H here, then we have C minus X here. So using our Pythagorean theorem, we have H squared plus the C minus X squared is equal to A squared. Okay, really does nothing for us right now because, you know, we still have a bunch of C's and X's in there. What our goal is to eliminate those C's and those X's, or I'm sorry, the H's and the X's as we go through. Well, how do we go about doing that? Well, let's take a look at C minus X squared. C minus X squared is C minus X times C minus X. We're multiplying it by itself, which means we have to go back to our algebra skills and FOIL this out. Well, if we FOIL this out, we have C squared minus CX minus another CX and then plus X squared, which then simplifies down to C squared minus 2CX plus X squared. I'm going to do two things here at once. Okay, we're going to take a look at this equation here, and I'm going to subtract X squared from this side, from both sides. So what we are left with is we're left with H squared is equal to B squared minus X squared. And what we're going to do with this H squared is we're going to use our substitution principle, which is replacing something with its equal. So my equal is B minus X. So I'm going to take the B minus X, or B squared minus X squared, plus, now I could take this from up here, give me C squared minus 2CX plus X squared is equal to A squared. Once again, just a lot of algebra going on here. But if we take a look, when we do both of these things, I have a negative X squared and a positive X squared. If I have a negative X squared and a positive X squared, they will cancel out. So if we take a look what we have now, and I'm going to flip this around, we have A squared is equal to B squared plus C squared minus 2CX. So what I've done is I've done a lot of algebraic manipulation, and I've eliminated the H's. I've eliminated most of my X's. I still have one X in there. Okay, we need to get rid of that X somehow. Well, if we take a look at triangle number 1, this is where we have an X. Also in triangle number 1, we have an entire angle A of the triangle, original triangle, and we have an entire length B of the original triangle. Here's my X, here's my B, and here's my A. Well, if we take a look at angle A and X and B, we ask ourselves once again, which trig ratio relates angle A to X and B? That's correct, it is the cosine. So the cosine of angle A is equal to X over B. Multiplying both sides by B, X is equal to B cosine angle A. And that's what we're going to substitute in down here. This X is the same as this X, is equal to b times the cosine of angle A. So what we're left with is a squared is equal to b squared plus c squared minus 2c times b cosine of angle A. This gives us what we call the law of cosines. This is the law of cosines, which relates three sides together and also an angle. Now, if we just take a look at the initial part here, the initial part looks like a Pythagorean theorem equation. A squared equals b squared plus c squared. But since it's not a right triangle, what we have to add, subtract off here is a correction factor because it's not a right triangle. Okay, so we have minus 2cb cosine of angle A. The other things you can take a look at here, if I have a squared on the front, I'm dealing with the cosine of angle A at the very end. Now, each triangle has three law of cosines equations. Each triangle has three law of cosines equations. Well, if we follow this pattern, if we would start this with b squared, if we start this with b squared, to follow this pattern, at the very end, the cosine of angle B has to be at the very end. Well, this is a Pythagorean idea. One side squared equals the other two sides squared added together. Well, what's my other two sides? Well, I have a squared plus b, or c squared. So I have one side squared is equal to the other two sides squared added together. Once again, that's a Pythagorean idea. Minus, now if we take a look at the coefficient of the cosine of angle A, here I have b squared and c plus c squared. Here was b and c. So if this is a squared plus c squared, this is going to be minus 2ac. I'm just taking these two, I'm not squaring them, and putting them there. So here would be another law of cosines equation. Well, as I stated, each triangle has three law of cosines equations. What's the third side? Follow the pattern and write it down. I'll give you a hint. It's going to start with c squared. What's at the end? Cosine of what angle? Cosine of angle C. My other two sides being squared, I have a squared equals b squared plus c squared. B squared equals a squared plus c squared. So c squared has to equal a squared plus b squared. The other two sides squared added together minus 2. And then this was a squared and c squared. This is ac. B squared, c squared, b and c. So I have a and b. So there is our third law of cosines equation. Once again, every triangle has three of them. Here we have triangle rat. Triangle rat. Now, as talked about every time in this class, the best thing we could do to help ourselves out is to draw a picture, draw a picture, draw a picture. Now, my pictures of my triangles all pretty much look the same. They don't have to be anatomically correct. They don't have to be drawn to any type of scale. They just have to be a triangle down there. So most of my triangles are going to be, tartar sauce. Most of my triangles are going to look like this. Now, what side do we label what side? That's up to you. Or which angle do we label which angle with? What I typically do, my thing is I start with my R up top and then go left to right with my A and my T. That's typically what I do. You do what you want to do. Okay, but you need to label your vertices. Then the sides opposite will be the lowercase. So I have big R, little r, big T, big A, little a. First thing you need to do is make sure you get those letters down, because then we're going to sit here and look at values. R is a value of 10, T is a value of 7, and the measure of angle A is 71 degrees. Now, what I want you to do is I'm going to want you to write 3 law of cosines equations, okay, using only letters and the cosine. A's, R's, and T's. I want you to write all 3 law of cosines equations, because this gives us practice. So, go ahead and turn it. If you want to watch me do the first one, then you turn off your video, you do the next 2, and then turn your video back on and see if I'm correct. I need to take one side squared, so we have r squared. Doesn't matter what side I start with, I have r squared. Then my other 2 sides being squared, a squared plus t squared. Once again, that should look like a Pythagorean equation. Minus 2, then I recopy a and t, and then we have the cosine of, if little r is at the beginning, big R is at the end. So I want you to turn off your video, write the other 2 equations down, and then turn them back on and check. I'll write them down here and you can check. If I started with a squared, this is equal to r squared plus t squared minus 2rt. Once again, just rewriting here. Cosine of angle. If I have little a at the beginning, I have big A at the end. And my last one, t squared is equal to my other sides, a squared plus r squared. Once again, looks like Pythagorean idea. And like, if you have r squared plus a squared, it's no big deal. No big deal. Minus 2ar cosine, little t at the beginning, big T at the end. Well, in this problem, what we're being asked to do here is we're given t is 7, r is 10, and measure of angle A is 71 degrees. I want to find little a. Well, if this is the only angle I know, I need to pick my law of cosines equation that involves angle A. Well, my law of cosines equation involves A as the second one. So we have a squared equals r squared plus t squared minus 2rt cosine of angle A. Now let's start substituting in. We have a squared is equal to r squared, which is 10 squared, plus 7 squared, minus 2 times 10 times 7 cosine of angle A, which is 71 degrees. Now the nice thing about this is if you use our calculator, you could type this straight into the calculator. You could type this straight into the calculator. We have 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of 71 degrees. Make sure I'm in the correct mode. No, I'm not. Need to make sure I'm in degree mode. Boom. There we go. It's a little bit better. So I typed in exactly what I had with my law of cosines equations. I don't have to do pieces parts with this. I can type it straight in as it is and then enter. And what this comes down to is 103.42. But now remember, this is what a squared is equal to. This is a squared. It's not a, this is a squared. So what do we have to do to both sides? That's correct. We have to take the square root. So we can take the second square root of my answer. Whoopsie. Of my answer. All that's going to do is pull down my answer from the previous line, and we get 10.17. And that's a measure of little a. If we look at one last one here, we'll just do one of these here. We have triangle BMX. Once again, as you notice, all my triangles pretty much look the same. Here's my B, here's my M, here's my X. Let's see, the little M, little X, little B. Little m is a value of 6, little x is a value of 8, and little b is a value of 12. We need to find the measures of angles here, the measures of angles. What I'm going to do is just find the measure of angle B here. We'll just do angle B. Well, if I'm trying to solve for little b, or angle B, that means we have to have the cosine of angle B at the end. So what has to be on the other side of the equal sign? Well, if I have big B here, this has to be little b squared. Now I can finish my law of cosines equations. Okay? If I write a law of cosine equation just using the b's, the m's, the x's, we have b squared equals m squared plus x squared minus 2mx. Now we can substitute in. B squared is a value of 12 is equal to m squared, which is 6 squared, plus x squared, which is 8 squared, minus 2 times 6 times 8, cosine of angle B. And what we need to do is we need to calculate the measure of angle B. Now, this is a little bit more work than the first type where you could just clickety-clack it straight through. My suggestion that you do, we have to subtract 6 squared and subtract 8 squared. Go ahead and find this value. So we have 12 squared. 12 squared minus 6 squared minus 8 squared, we get 44. On the right hand side, what I would suggest that you do is take these values and multiply them together and get one coefficient for the cosine. Now the key is don't lose track of this negative sign. So we have a negative 2 times 6 times 8. So we have negative 96. Cosine of angle B. Okay, I suggest you multiply these and don't lose track of that negative sign. Now we can divide both sides by negative 96, by negative 96. Don't worry about doing calculations yet. Just show this fraction here, because to solve for angle B, what do we have to do to get rid of the cosine? We take the inverse cosine. So we can take the inverse cosine of 44 divided by negative 96. So we have the inverse cosine, second cosine of 44 divided by negative 96. Close my parenthesis out, and I get 117.3 degrees. I think that was at 117.3, yes. So that's a measure of angle B. And I could do the same for X and M also. Law of cosines allows us to be able to solve equations or solve triangles when it's not a right triangle and I just don't have sine, cosine, tangent and my trigonometric Indian that I can sit there and work with. Okay, so we can look at law of cosines to be able to solve for values of a triangle, lengths and sides of the triangle. Okay, what I added at the very end is I add you a couple problems here at the very end. Basically some law of sines and cosine problems that you can work for an answer to give you some additional practice. Once again, tomorrow will be a review day over the arc trig that we did yesterday and also the law of cosines we did here today. And then Thursday and Friday will be the evaluation for the week that we have. If you have any questions, feel free to comment to me. I will answer your questions whenever I get to them. Other than that, I miss you guys. Adios. I'm out here. See you tomorrow.